In this clip, we will watch a time-lapse video that shows us a room inside one of our training props during a burn. This time-lapse will allow us to watch as the room and its contents are affected by hot smoke, and we can keep track of how thermal imaging camera visibility changes during the life cycle of the fire. This room is remote from the fire, but the window seen in the upper right side of the display opens directly to the fire compartment itself. The video began recording as the fire was lit, but we will speed things up for a minute or so we can see the changes occurring more clearly. As the time lapse starts, watch as the window grille begins to heat up as fire gases enter the room through it. Going back to normal speed, we can see the gases entering the room quite clearly. With the naked eye, this room is total darkness. Let's speed it up again and watch how the room heats up over time. Different objects heat at different speeds according to their construction material. This provides a good amount of contrast in the earlier stages of the fire life cycle. However, the longer we go on, the longer the hot fire gases continue to radiate heat down onto the contents of the room, and the closer the room and the contents come to reaching the same temperature. Here we can see that the upper section of the filing cabinet has been heated more than the objects around it. Due to it being taller, it is being exposed to hotter fire gases. If we have a look at the right-hand side wall, we can notice that it is uniformly hotter from top to bottom, once again suggesting to us that the fire compartment is on the other side of that wall. From this point on, we can see the thermal imaging camera view continue to deteriorate. This is a combination of temperatures becoming more uniform, as well as a steady increase in the amount of particle matter in the smoke, as well as steam created by firefighter activity, and also moisture generated by the combustion process itself. All this combines to give a grey out situation, where the tick no longer gives an image that can be easily interpreted. Let's slow the video back down again, so we can get a bit of an idea as to what it may look like for a crew entering this compartment at this stage in the fire's progression. As you can see, in real time we can barely make out any of the features that were clearly visible in the room before the fire started. We can't see the furniture, and we can also barely make out the actual dimensions of the room. When confronted with conditions like these, it is easy to see how some firefighters come to the assumption that the tick is malfunctioning, the danger being that the operator dismisses the tick for the rest of the job. As the hot smoke is trapped inside this enclosed compartment, this image will stay grayed out until something happens to create a greater range in the visible temperatures. Let's fast forward again until our crew makes an entry at the rear of this compartment. This part of the time-lapse covers around about 15 minutes of real time, where fire crews are working just outside the room we are viewing. Even remote from their location, we can notice that the ambient air temperature goes up and down as the firefighters bring in fresh air and also attack the base of the fire outside. Remember, every time you open a door, you're letting hot smoke out and fresh air in. Back to real time, and we can see that although the room and its contents remain heated, the atmosphere has changed as firefighters opened the structure to gain access and smoke escaped. The visibility seen here is only due to the actions of the fire attack crew over the last 10 minutes. It is highly likely that the next structure fire you attend will present you with the same grayed out view as seen in the middle of this clip. Presented with such an image, it is important to continue on with manual search and navigation techniques and to recheck your tick on a regular basis to see if imaging conditions have improved. In the remainder of this clip, we can see our search and rescue crew come into view. Number 1 on the branch is controlling conditions as they advance with regular short pulse gas cooling. Number 2 is utilizing the tick to navigate and direct number 1 through the compartment. At this stage, the tick operator has noticed an item of interest, a possible casualty on the bed. They move up the hose line to share this information with the branch operator, and they agree that number 2 will take the branch and number 1 will collect the casualty. Now number 2 turns around and continues to gas cool, providing protection to number 1 as they retrieve the casualty. Although there are no hard and fast rules on which member of a BA crew collects the casualty, the benefit here is that number 2, whom has the tick, is free to use it to direct number 1 back out of the structure with the casualty safely. Also, as typically number 2 has been working hard dragging hose throughout the structure, swapping like this allows for the heavy lifting to be shared, which results in more even air consumption between the team members. In the last few seconds of this clip, we can see number 2, whom is continuing to control conditions, turn around to wrap the hose around behind them. This technique allows the branch operator to push the hose with their back as they retreat, keeping their branch pointed towards a hazard to cover the team from any possible extreme fire behavior. Don't forget that even with thermal imaging, visibility will change drastically throughout the incident, meaning you should check the tick a little bit a lot and always be aware of your surroundings.